everyone. This is the libhal biweekly meeting, and today is November 4th, 2025. Technically, I'm actually recording this on November 5th, but I'm going over the same talk just because I was having some internet issues before, and I wanted to kind of go over things again. All right, for the agenda, we have the conan-hal-command. We're going to discuss the split from v4 from v5. We're going to talk about the v5 library split, v5 coroutines, v5 modules, as well as v5 type safe units. Let's get into it. First, the conan-hal command. We have conan-hal setup. This runs through the libhal getting started guide for you. So it'll install your remote, it'll install your compiler profiles, it'll install your ARM-MCU profile, and we do plan to support any profiles that we add into the future. We'll have hal setup set it up for you, so you just have them all available once. And then here's a link to the conan-hal command. I'm actually going to go to this real quick, and we're going to take a quick little look, and you can see we have the hal conan setup, which explains what it does, but I really just want to scroll over and look at some of the future commands. So a couple of the things that I want to add to this is conan-hal new. This will be for a new application, it should say, not just project, but application. I think that makes a little more sense. Device library, platform library, and a board library. Also on the application side, I've also been thinking about having different types of applications. So currently most of our applications are multi-platform single application or multi-platform and multi-application. I think there's a use case for just a single application, single platform. I think there's a lot of users who just don't really care about like needing to support multiple devices, and I think making that easy and simple to just whip up a libhal project would be great. Here's a convenience function for CI for download the compilers. Then we have build and package. This does not take over or replace Conan build. This actually is meant to build matrices. So what build is expected to be built for is to allow you to build across all the profiles and all of the architectures that we support in profiles, if that makes sense. Basically allows you just to do a build matrix and package. This does it just locally for your build, and this does it for your packages. This should also double up for doing a build matrix for a application or project. So yeah, this will be kind of powerful to do a lot of things all at once. And then we have how flash and debug. This part is a bit interesting because I need to figure out what I should do in order to support flash and debug, since it will require you to have certain things already installed on your machine, like PyOCD, or for flashing NXP-prog and STM32 loader. So I'm still figuring out how I want to go about making sure those are pre-installed on your machine, either making you install them or having the command do it for you. Not sure. All right, let's get back to the presentation. All right, let's talk about the split v4 from v5. What's happening? Well, rather than mix the v5 stuff, which is what we've been doing, all the v5 interfaces, and v4 for a gradual migration, we're gonna make a clean break between v4 and v5. Any of the v5 symbols or classes, interfaces, they're gonna stay where they are, most of them. Some of them have been deleted because they weren't used anywhere else in the project, and I know none of the other clients that we have are using them. So that is a bit of an API break, but I already made a notice saying that anything from v5 can break at any time, so it wasn't stable anyway. But the ones the symbols in v5 that we think are appropriate for v4, like velocity servo and open loop motor and those kind of things, those are being moved into the hal namespace so you can use them normally in v4. There's one thing that doesn't do that right now, and that's serial, v5 serial, because it conflicts with hal serial. I'm thinking about making a using namespace for that, which is like serial v4 or v5. I'm sorry, serial v2, since it's the second version of it. Yeah. Now, why are we doing this? Well, if we can isolate v4 from v5 changes, v5 can do API and ABI breaks without causing issues to v4. This should say v4 here, apologies. But the main thing here is we're gonna make a lot of changes with v5, and trying to mix the two is gonna be very confusing and problematic. I actually liked it before when we were gonna do a gradual migration, because I think it would have worked out just fine. But the moment I realized that I wanted to move to modules and I wanted to, have async stuff everywhere. The types of things that will be included in places. Basically, I realized that I really just want a clean separation, a clean slate to work from. Now, V4 isn't going away anytime soon. Unlike V3 and the other ones, which were more incremental in their changes, I plan to continue service for V4 for the rest of 2024 for the robotics team, but I don't plan to do this for any other clients. And the hope is to get them to move over to V5 when that's ready and stable, because it's nowhere near that. There's so much things we have to get done and worked on. Also, we will allow additional interfaces to be added into V4. We're not going to limit at that, although I'm not going to try to add too much there. Also, I'm not going to put in too much rigor. That doesn't mean that we just add anything in there and just kind of make it into a dumping ground of interfaces. That would be confusing and annoying. But I'll be allowed for more experimental things. We don't have a display or a camera interface, and maybe we can get those in even if they're not perfect. That's kind of what the less rigor is for. And one last thing on the less rigor, just means that we can maybe test some things in V4 before we put them into V5 and make them stable. All right, V5 library split, strong pointer. So we're actually going to remove strong pointer from the libhal project just because there are users who want to use it, specifically the Atlas engine, without having a dependency on libhal. Like, all I want is a memory safe pointer, smart pointer, or a safe to use smart pointer, and you've made me include all these other interfaces for hardware. That doesn't make any sense. And a bit of a recap for anyone who's doesn't know what strong pointer is. It is a smart pointer like standard shared pointer and standard unique pointer, but built to A, provide strong non-null guarantee for the mem strong pointer template type. What this means is that if you have a strong pointer to a type, it is non-null. It cannot be null, it's non-null, meaning that you can always access it. The operator asterisks, the operators to access the memory inside of it will never do a check because it's never null, so it doesn't need to do a check. When you have a strong pointer of something, that thing exists. That's the goal. Also, shared pointer has a pretty large memory footprint for ROM, and I'd even say for RAM. I gotta relook at the RAM costs just to make sure for the control block, but I know for the ROM size it's a lot. Basically, internally, I think in order to erase, air quotes, to erase the allocator and maybe some other specifics about the type, it uses a template of a virtual class, and it's based on the base class that you provided. And the APIs that it provides are like dispose, delete, and one other thing. The thing I dislike about these additional this additional interface, I'm told I love vtables, I love all that stuff. I just don't think it's the right place. For strong pointer, we replaced the entire vtable stuff with a single function that's templated called destroy. If you pass it a pointer, it'll call the destructor for the type that it was templated off of. And we just store that inside of our control block. Cool thing about that is you can also get the size of the object just by calling the destroy function with the value of 0. I just find that neat. It was a way to kind of combine two things at once to really get the code size as small as possible, and it worked. Really good ROM reduction. No real concerns when it comes to memory usage, when it comes to strong pointer. One thing that I asserted is that rather than allowing for arbitrary allocators like strong shared pointer can do, we just use PMR memory source. I don't think there's going to be any cases where, since we normally do allocation at initialization, the cost of calling a virtual function to allocate stuff is going to be nothing. Like, I don't say nothing, but it's going to be inconsequential. Yeah, I don't think this will be a problem. So this is perfectly fine. So we actually require the usage of PMR memory source. It's a dependency of strong pointer depends on this. And we do all that stuff through this so that you can get full control over how you want to implement this without needing extra like template types that kind of make the strong pointers incompatible with each other. Shared pointer does not have that problem, just so you know. I just made sure that we wouldn't end up with that issue. Also, if you need a nullable strong smart pointer, we have optional pointer. And the reason why I consider it safe is because if you try to access the memory of an optional pointer and it's null, it'll throw an exception. It's a bad access exception. The idea here is you cannot access anything through the strong pointer class and any of its other templates in an unsafe way. It'll just throw an exception. It'll do something else. So there's no way to get around this. If you ever want, and one thing to know about optional pointer before I move forward is that every time you try to access it, it'll do a check to see if it's non-null. That's there's some expense there. Not the worst, but there's some expense there. If you want to eliminate that, you should convert your optional pointer into a strong pointer, checking it that it's actually not null. If you do that, if you try to compare them and it is null, it'll throw an exception. So you can't even try to make sure there's no ways for you to incorrectly access memory without using reinterpret cast or something like that. But yeah, if you want this to work a little faster, you turn it to a strong pointer and use the strong pointer. Oh, and then finally, internal type safe internal references via member functions, member pointers. Member pointers are not the most enjoyable thing to work with. I don't use them very often, but I very much disliked shared pointer in that it allowed you to take a void star into anything and just say that it's bound to the shared pointer. I don't think that's I don't like that. The internal references also have some other cool capabilities, such as because you need a reference to internal members, the because you need internal references to members within an object. If they're public, then anyone can access them. If they're protected, then your things that inherit you can provide those internal references. If it's private, only the class that has access to those internal members can actually use the member pointers. So that ensures, and you need to have type information, like it has to match the same type. We make sure that the member that you're looking for actually exists within the T that you created for the original smart pointer, or strong pointer. So yeah, that's pretty much that. The split's just because other people want to use it, and they shouldn't have to depend on libhal. All right, the next split, async context. All right, so a quick little recap on async context. What is it? Well, it's an implementation of the C++20 coroutines built to support libhal embedded targets. Specifically, an async context itself, the type, is a stack frame allocated by a PMR allocator that a coroutine can be. Actually, I'm going to move to the next slide here because I think this does a little better job of explaining it. I actually made 2 slides for this and delete the previous one. So basically the C++20 coroutines built to support libhal embedded targets. Rather than allocating memory via the global heap, an async context is a container for a coroutine stack, a block by state, and a transition handler. We'll talk more about that way later, but the idea is that just like an RTOS task, you can just give it a stack memory to run over, and it'll run through it. You can allocate coroutines the same way that we allocate function frames, but think about them like being orthogonal. So you have your normal function frames that your CPU works with. Then you have, in a perpendicular to that, you have your async context, which can, every time you go co-wait or something like that, and you have another function you're going to call, another coroutine you're going to call, it'll use the memory in the stack after the previous frame. Nice and compact. There's a block by state that tells you what state the operation was blocked by, either by IO or something like that, and a transition handler to handle what happens when you are blocked by something. So why the split? Well, same as strong pointer, others want to use this library without libhal. Makes sense. If you do this project's actually pretty generic, so there's no reason to have it bound to just be used by libhal. Featured types. We have context, which we already went over. We have async future type, which is a coroutine return type, which is a variant of T and a coroutine handle. What does that kind of mean? Think about it like this. When you call a function that returns back a future T, you either get back a T, meaning that the operation you asked for finished and give you back a value, cool, or it says, hey, I can give you back the value. Here is a coroutine that you can execute in order to get the value. When that coroutine finishes and returns, finishes off, the T should be created, and it should be available and you should be able to access it. Once you get the T, the coroutine handle and everything else responsible there is all destructed, gone, and you just have your value. Note that futures are expected to end. There shouldn't be a case where you have a future that runs forever. At some point in the future, it should give you back a T. Next up, we have async task. It is an operation that can suspend itself and be resumed by a caller. Typical async coroutine stuff, but you can think about this literally as being a task. You just run operations and do things. It doesn't yield back a value because the idea is that these are just operations, like they're like processes that you can just run. If people feel like this is too close to the C++ task type that also returns back a T, I can also change this back to process, async process. Might make the name change to that actually. Processes are allowed to end, but do not necessarily have to end. You can end them by dropping them or destroying them, but they don't need to end on their own, but they can. Then we have async generator, which is like future and task, but it can generate and report back multiple of T. A coroutine type is a handle and an optional type, and the idea is that yeah, every time you call it, you can yield back a value T. These can end, but they don't necessarily have to. They can run forever if they want to. All right. V5 coroutines. We already talked about the split up, but what we're going to do is after we split up async context into its own library, we're going to bring it back as a dependency of libhal, and all of our virtual APIs will be async future of some T. And the first parameter will always be an async context because you need this in order for this whole coroutine system to work. It uses this in order to perform its allocation. And from going, for the moment, generator T and task T, which might become process T, or it shouldn't actually say T here, that should be removed. But for task and generator, these will not be allowed for interface APIs. And there's some code of like kind of showing what it would look like if you wanted to set the level and then sync weight it. One of the students did bring up something interesting, or not, I should say students, but one of the contributors of this project said something very interesting, which is, does it make sense for input pin to be async? Like, couldn't we just omit the async part for this one, only put in things that we know will be async? To which I clapped back and said, no, this has to be async because it can be async. To which they were like, how could it be async? I was like, because it can be implemented via I2C. The libhal interfaces are not meant to be, they don't specify, I don't want them to specify the exact environments in which they should operate. I don't believe that input pin should be limited to just a pin in your MCU, and therefore you just hit register and you're done. I also don't think there's a good idea to make a sync input pin and an async input pin, because then you'll have a mess everywhere. If you have an input pin, whether controlling it is over Wi-Fi or over some SPI link or USB or I2C, or just through a register hit, we need to be able to support async. Now you might think to yourself, okay, well what happens if I call this with this thing here? I have to plumb it down, but I have to call all this stuff, and this actually is performed synchronously. No worries. I did some testing, and for the most part, coroutines are great, because if your function's not actually a coroutine, it just gets called. That's it. And this will return back finished, and you're done. If this is synchronous as well, it'll return back true or false, and then you'll have your answer. And that's pretty much it. This allows you to go synchronous, but does not require that the implementation be, asynchronous, but it doesn't require the implementation to be asynchronous. So you only pay for what you actually use. And yeah, because I2C is going to be asynchronous, and we might have an IO expander for the input pin, and we want to represent that input pin from that IO expander, talking to it and trying to set that pin will be asynchronous. So you'll need that there. All right, and then V5 modules. V5 will move entirely over to C++ modules. We're going to eliminate all the clever things we do with headers to ensure fast compilation. You see, all of these files here, all of them, we split these up a lot because we don't want to have users pay for what they're not using. Like, if you're only going to use some constants and GPIO, you shouldn't have to include everything else here. It's just a lot of extra stuff. And if we had just one single file to include everything, kind of like a Unity build in sorts, every single file that has one of these headers, it's going to be a little slow. I have spent probably more than a decade working on ways to improve header usage in order to make things fast. Currently, things are very fast for libhal. I am very happy with how fast our build system and everything else is. The thing that I don't like is just the verbosity of all of this. The fact that you can be error prone with all of this. The fact that I have to even remember all of the clever things we have to do in order to make sure that their headers are going to be fine. Like, it's honestly just, I realize now it's a waste of time. And actually, one other thing I'm going to say is that, like, on the less error prone, man, we have faced 2 separate header issues in the last week. One of them was because we forgot to add, where is it? I don't know if it's in here. Libhal error. It's not in here for some reason, but I didn't have libhal error in one of my source files. But all my tests showed that it was there simply because of the fact that something else included it. Something else hash included it somewhere else. I might have included, and I sort all of my includes by alphabetical order because I don't think the ordering should matter. But looky at that, the ordering did matter, and it happens to matter all the time. We fixed that, but I don't think this would have happened if we had used modules. So I believe that in the future, they're less error prone, there's less code for you to copy and paste, and it gets rid of all of the crap that I had to remember. We all had to remember in order to use headers correctly. So all of this would turn into just this into the future. That's the goal. And I love this page because it kind of shows what all of the different modules, I'm excited for a future where I can just say, hey, here's the list of all of the modules you'll ever have to even consider. And that's it. If you just look at the non-platform stuff for a sec, this is pretty much all of the imports that you could ever have with libhal. That's it. These are all the generic libraries. Here we have ARMMCU, which has basically an infinite number of things. We just have a few of them listed out here. But they're all underneath the ARMMCU umbrella. RISC-V is the same way, so this is a bit of an open set, but it's limited to just the things that you need. Boards is also an open set, but this is what we'd have for just the micromod. And then we'll have one for import Linux, Mac, Windows, FreeRTOS, ThreadX, and real-time stuff. We're gonna have a very small set of modules in the end, I believe. And I'm pretty excited about that. No more crazy include files, just simply import, 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 and done. Then finally, we have type-safe units for v5. We're going to be moving over to MP units for a couple of reasons. So one, we've been using floats right now for all of our units, and we knew that we wanted to move to something type-safe. We wanted to move something type-safe, and I have been playing around with units libraries for years now, at least more than 6 years. Oh man, it's crazy saying that, but I didn't like how they worked back in the day. I didn't use MP units as much back in the day, but I didn't like how the other ones worked, most of them. But I like how MP units looks now. And here's some of the reasons why we're going to move over to this. You get automatic unit conversion between compatible types. So if you try to convert Kelvin to Celsius, it'll work. And then you'll get back Celsius. And you don't have to do any math or anything like that. You just set it equal to some value that is, some quantity that is in Celsius. Unit operations are expressive, and I'll show you a little video, kind of what that looks like. And I hope to work with Matus to kind of work on standardizing C++ units. MP units is kind of the framework for that, and I agree that I think it's the right choice in terms of its design principles for standardization. And I really do want to use it for libhal in order to basically have proper safe units. Once we have that, we have safety in units, we have safety and memory safety to some degree, mostly. For the strong pointer and that kind of thing. And we'll use modules to make our importing and usage of C++ easier. I don't expect at all, actually, take a little note about v5 modules. I've worked with pre-compiled headers, which I believe is what GCC and Clang utilize in order to make their modules work. They work actually pretty well. They're not, I think maybe I would have thought there would have been a better solution, but I think just using that is fine. I don't expect our build times to get any faster with modules. I don't care about being faster with modules. I just care about not having to deal with weird hash include mistakes and issues everywhere. So yeah. And yeah, that's pretty much it. That's the libhal meeting for this week.